Guys, your favorite intermediate algebra course. We're going to take a look. Last time we took a look at exponential growth. Now we're going to take a look at exponential decay. We have the definition here: f of x equals a times b to the x. A's got to be positive, and b is any number between 0 and 1. Okay, any real number between 0 and 1. So let's look at let's let our a be 1. Let me do this in red. Start off. So let a be 1. Let b be a half. Okay. So let's go ahead and graph. Let's call it g of x is 1 half to the x. Of course, we don't have to write the old 1 out in front of that 1 half there. Okay, we're going to plug some points in. 1 half to the 0 power. Of course, anything to the 0 power is 1. Let's plug 1 in. 1 half to the 1 power. Of course, is 1 half. Let's plug 2 in. 1 half now squared. That's 1 squared over 2 squared. So 1/4. Let's plug in 3. 1 half cubed. 1 cubed over 2 cubed. So 1/8. So on. Probably see what that's doing as this keeps going, gets bigger and bigger and bigger. 4 would be 1/16 and so on. So as this x value gets larger and larger and larger, as we run to positive infinity, you see how it's going to go. We went from 1 to 1 half to 1/4 to 1/8 to 1/16th, 1/32nd, 1/64th, and so on. And so your denominators get larger and larger and larger as your numerator stays 1. So this thing is going to be approaching 0. Let's go to the left of 0 now. Let's click, how about -1? Okay, so we have that horizontal asymptote there, y equals 0. But again, let's go to the left. Let's pick a -1. Let's go 1 half to the -1 now. Okay, 1 half to the -1. Of course, that's 1 to the -1 over 2 to the -1. So that 2 to the -1 in the denominator goes up there. That 1 to the 1 to the -1 goes down there. So we got 2 over 1, right? 1 half to the -2. So 1 to the -2 over 2 to the -2. So that becomes 1 squared on the bottom, 2 squared on top, 4 squared. 2 squared is 4 over 1, and so on. And so let's go 1 half to the -3. And sometimes people just do it this way. They flip it over 2 over 1. Make that to the third. So 2 to the third over 1 to the third, which is 8, and so on. And we could keep graphing these, but now you kind of get a feel for that. If you remember the old rules from negative exponents. Alright, so 0, 1. 1, I'm only up halfway. 2, I'm only up 1/4 of the way. 3, I'm only up 1/3 of the way. So you can see that this thing's lower and lower and lower, right? So we got this horizontal asymptote at y equals 0. Again, okay. -1, we're up 2. -2, we're up 4. -3, we're up 8. So if I can hit these there, whoops, got this there. Alright, so there's an exponential decay model, okay, where again our a out in front would be positive. In this case, our a is 1, and our b is a half. Our b value is anything between 0 and 1, and our domain here, similar to exponential growth, our domain here is all real numbers. You can see how it encompasses every x value. In our range, you say, well, what's my lowest y value? I don't have any y's, right? No y's here, no y graphs as I'm going low to high. And all of a sudden, the first one is not quite 0, right? So we don't ever hit 0, but then you notice that the graph shoots up from there. So it's anything greater than 0. It's going to be our y value. So y such that y is greater than 0. Okay? Similar to the exponential growth, we're going to shift this around a little bit. So why don't we put a couple more graphs on here. Let's do the first one. Let's shift this down 3. So we'll take the original function and we'll shift it down 3. So you put a -3 there. That means the horizontal asymptote has been shifted down 3, right? That 0, 1's been shifted down 1, 2, 3 right there. Okay, that 1 comma 1/2, that's down 3. 1, 2, 3 right there. That 2 comma 4, that's down 3. That negative 1 comma 2, that's down 3, and so on. Anyways, you get the feel of this thing. You're like, oh, it looks the exact same. It's a rigid transformation. It's just down 3. Okay, so vertical shift down 3. If you're not quite sure, you can always plot points, right? Vertical shift down 3. And again, you just plot points. Plug in 0, 1/2 to the 0, 1, 1 minus 3, negative 2, and so on. You do a bunch of those, okay? All right, let's shift it right and left. How about, let's go, when we shift this thing to the right 2, okay? What would that look like if I shifted this to the right 2? Let me erase some of my original. Let me go right here. Okay, so that would be a composition. If we're going to shift this thing to the right 2, okay, that means up there in that exponent, we're going to have an x minus 2 up there in the exponent. That right there is our horizontal shift, right 2, okay? Because what we're doing is we're taking the original function and we're shifting it right 2. So that is that. You're inputting x minus 2 in for x into the original there. Okay, so g of x minus 2. Whoops. Something there. If you're not sure, plot points, right? What's the first x value you're going to plug in? Well, you want that to be 0, right? Because anything is 0 power. Anything is 0 power is 1. Okay, so I'm like, well, let me plug in 2 then. That'll make it nice. 1/2 to the 2 for x minus 2. So that's 1/2 to the 0, which is 1. Right? Let's plug in 3. 3 minus 2, 1. 1/2 to the 1, 1/2. Plug in 4. 4 minus 2 squared, 1/2 squared, 1/4, and so on. Let's go to the left of 2 now. So I want to pick an x value of 1, maybe an x value of 0, and so on. So 1/2 to the 1 minus, whoops, 1 minus 2 is 1/2 to the negative 1, or 1 to the negative 1 over 2 to the negative 1, which is 2 to the 1 over 1 to the 1. So 2. Let's plug in 0. 1/2 to the 0 minus 2. 1/2 to the negative 2. That's 2 squared over 1 squared, right? Or 4. So 4. Anyways, we go back up to our graph here. We plot those. 2, 1. So it took this original point 0, 1, it shifted over right 2, didn't it? Okay. So we have that point 0, 2. Or I'm sorry, 2, 1. And then we got the point 3, 1/2. It took that 1, 1/2 and moved it over 2. All right. Took that point negative 1, 2 and moved it over 2. So that's now 1, 2. And then it was 0, 4, and so on. But anyway, same thing as the red, shifted right 2. Okay? Shifted right 2. Let me erase this. All right, last one. How about, what if we made it, instead of 1 in front, how about a negative 1/2 to the x? Well, you plug in 0. 1/2 to the 0 is 1. And then you got that negative out front, so all of a sudden it flips it over to 0, negative 1. So it's right here, right? You plug in 1, 1/2 to the 1, 1/2, but then you apply the negative out front, negative 1/2. So 1, negative 1/2. That's right there. 2, negative 1/4. Let's plug in negative 1. Negative 1 is going to end up, instead of being a 2, it's going to end up being a negative 2. And soon enough, you see the black right there. You see how it's just a reflection. That negative will reflect about the x-axis. Okay, so those are some transformations for exponential decay. Okay, and it always, when in doubt, just plug some points in, take a look at it, and see what it looks like. Okay.